Hi all, in this video I will introduce how you can apply some of the tricks that you can learn from the lecture today to write your shellcode. And let's start with the changing the name of the bin.sh to some other thing, because creating the //bin/sh, that string requires many bytes in writing your shellcode. So I will just creating one simple binary program, bin.sh as a character name, capital A. So we can do that by copying the program bin.sh to A. Then now we have a program A here. If we run that, it's just a shell, but now the program name is A. So we just change the name. So instead of the running bin.sh, I will run character A. Let's try that. So in shellcode.s, so I will run set egid first, get egid first. So to do that, push sys get egid pop eax and int 0x80, and then set regid get egid get egid. That's the next step. And to do that, push sys set regid pop eax int 0x80. And then before doing that, we need to set the arguments. So push eax pop ebx, push eax pop ecx. Then we just move the value to ebx and ecx, and set the register as a eax as a system call number, and then call the syscall. And then we need to do exec b a 0 0, and then to do that, push sys exec b pop eax cltd, which we learned today. So then edx will be 0, and then push edx pop ecx, then ecx will be 0, and then push 0x41, which will push the character A on the stack, and then push esp pop ebx. Then now ebx points to character A, and then int 0x80. So we just write a little shorter shellcode by removing the bin.sh string here. Yeah. And then let's check if this shellcode runs. Make 32, and then shellcode, it runs. And then if I run shellcode 32, it also inherit the privilege. Then so now we have these much instructions, and then its opcode size in the shellcode.bin is we have a 26 byte shellcode right now. Yeah, and then to pass the short shellcode, you need to reduce it further. And then some of the tricks that I taught you is like you can remove the requirement of the running get egid and set regid by creating a binary program. And let's do that. So in doing that, I will create the small a.c, and then in the main of that function, what I will do is set regid get egid. Forget to type e here. Yeah. So inherit the privilege, then execl bin.sh 0. That's it. Yeah, then it will inherit the privilege and run bin.sh. And then I can build this file. And then if I run small a, then it's just it will execute the shell. Yeah, because internally it will run this, and before that it will inherit the privilege. So the only requirement for doing this is like that we need to run this before running bin.sh. That's it. So we don't need to include this in the shellcode. So right now I will reduce the shellcode further. For example, So I can remove all these lines, but I will just comment out these. And then right now we need to run small a, not the capital A. So the small a is 61 in ASCII code. So let's do that. Make 32. Now our shellcode size is 12 bytes. Make obj. So now you can reduce further bytes by just replacing. So now you have like a 12 byte shellcode by removing the requirement of the /bin/sh and using the tricks of the push and pop and setting the register values like this. And how can you reduce the length of the shellcode further? And one of the things is like that you can reuse some of the values on the when running the shellcode. So for example, you may reuse some of the register values, and then to check that, get into GDB, and then shellcode 32, and if you disassemble main, then you can check that where it calls the shellcode right here at the end of the function. Then set the breakpoint at there, then run it, and then getting into that call instruction by doing SI. So that this is the status of the registers. So right now you have EDX as a 0, so you don't need to make EDX as a 0, so you can remove this CLTD instruction, right? Let's apply that. So you don't need to do this because EDX is already 0, right? Let's try it. Make obj dump. Now we have only these instructions. Now it's 11 bytes, and then it works, right? Yeah. And then we can further reduce this thing, and then let's reuse some more thing. And then, as I told you in the lecture, let's try to reuse some of the string in there. So break at main plus 349, run it, SI. Then right now the value in ESI, it stores FBAD240C. ESI stores this integer value, and then if I print out values from here, 0C, 24, AD, FB, and 00. So the ESI points to the string as 0C, 24, AD, FB, this string, because it ends with 00, so it's just a 4-byte string. And then let's reuse this string, and then not creating this A on the stack. So to do that, now we know that ESI, so this part, now we know that the ESI stores the address of the string. So instead of doing this, push ESI, pop EBX, then EBX will be the string. Then make 32, and then to quickly check that, we can use strace, and then run the shellcode, and then it tries to run something with the exec VE, but that's actually this program, because we can actually check that. For example, we do gdb shellcode 32, breakpoint that the main plus 349, run it aside, and then if we run the instructions, then right before running execve, now the path is this one, so it will run 0c24adfb. Then the problem is that you guys all want to create a symlink to this program A to this string. Where is it? This string, yeah. And to do that, we will write a small Python script. So I will write the c.py, yeah, and then import os.symlink, source and destination. So we will link this to this. That's it. And then I will print the return value to check if it is correctly run or not. And then if it returns 0, then it's successful. So run python c.py, and then it's none, so it's successful. So it created something here. And then if I run shellcode 32, it runs. So it runs sh by running this program. And then right now, our shellcode size is 9 bytes. Yeah. So we can reduce number of bytes by reusing some of the string. Yeah. In the status of the some of the register before running the shellcode. I hope this helps you. And then please check these files a.c to reduce the requirement of the running get EGID and set EGID, and also running the simple Python script to create the symlink. And then to remove some of this file, and how you can do that is you can call os.unlink with the file name. So if you do that, maybe at the first place it will show the error because this file exists. So what you can do is remove it first and then run it and remove it. Then now the file has been removed. So you can use os.symlink to create an alias with the non-ASCII character, but you can also use os.unlink to remove that symbolic link. And I hope this video helps you in writing more shorter shellcode. Maybe you can write a shellcode shorter than 9 bytes. Yeah, please try that. And my minimum was 2 bytes, so yeah, please have fun with that.